Hello, everyone. Thanks for tuning in. And I have the pleasure today to introduce Enid Kivuti. Enid is Technical Director at Sheldahl Flexible Technologies, which is part of Flex. And I am joining her today, Marco Angeli, Senior Director Innovation at the Center of Excellence at Flex. And yes, today both will share their insights about printed sensors from concept to production. Over to you two.
Thank you very much, Christoph. So we organize the presentation into sections. I will cover the early concept phase of these printed sensor technologies, and Enid will take care of sharing what happens from the concept to production. So just as an icebreaker, and starting talking about sensors in printed electronics, we use the reference example about a liquid detection, so sensing of liquids in a wearable sensor as a case study. And just as an introductory slide to give you an idea of the typical technologies that we have to deal when we are working on wearable sensors, we are talking about typically large area sensors where a low-cost substrate makes totally sense. Substrates with conductive traces to read out voltages or currents or signals like an ECG sensor, or even some functionalized substrates with the ability to emit light or measure light in specific sensor applications, or up to the RFID portfolio with all the typical printed antenna and on flexible and organic substrates. So we'll focus more on the first concept, so how we can design a sensor based on conductive inks to detect the presence of a liquid. And this brings us to the first somehow electronic engineering content. So typically, if we want to detect a liquid that is expected to provide some conductivity, the option is to run a current through the liquid and measure a voltage, or apply a voltage and measure the current that passes through the liquid. Of course, you need a pair of electrodes, typically even maybe 3 if you want to have a very accurate result. And these electrodes are some of the first interface between the electronics and the liquid that needs to be measured. When we talk about current and voltage, first thing that comes to mind is this is a resistor. So actually it is not. It's a very complex electrochemical cell where the ink has its own contributions, the liquid has its own contribution, and of course the electronics and how the bias signals driving the cell has its own effects. Before going deeper into the electrical composition of the system, first reminder about safety. So if we are talking about wearable devices, we are injecting current or applying a voltage, and even if these devices are typically battery operated, totally isolated from the AC mains, there is a safety requirement from ISC that we need to respect. And if we look at what is requested, typically we cannot go above 10 microamps of DC current, or 100 micro if we are able to use a AC current to drive a sensor. So this is quite a strong limiting factor from an electronic architecture. Just a basic starting point about the sensor and the liquid. So we are talking about a electrochemical cell. And what you see here in the picture is what is called the double layer capacitance structure of this kind of cells, where you have an electrode, a positive and negative electrodes that are biasing the liquid with ions inside, with conductive elements that are moved by the electrical field and are moving carriers, moving charges from one electrode to the other. Typically, this behavior is depending on the ink. The ability to exchange charges with the ions in the liquid is dependent on the timing where we apply the voltage and for how long. And indeed, this kind of capacitance effect creates a sort of rechargeable battery, I would say, that makes the impedance, the resistance exposed to the sensor changing over time. So the best way, or what we thought is a good way to understand the behavior of the ink, is to use a setup based on